Welcome to my lecture on area computation using coordinate method. The rectangular coordinates of a point in a Cartesian plane is denoted by an ordered pair of numbers x, y. X, y are the respective perpendicular distances of the point from two mutually perpendicular reference axes, which are referred to as the x and y axes. So we have the two mutually perpendicular reference axes, x and y, and we have a point P with coordinates x, y. X refers to the abscissa, which is the distance of P from the y-axis, and y, which is also called the ordinate, is the distance of the point P from the x-axis. So here are several points and their respective coordinates. You have the point 2, 3. The x-coordinate is 2 units from y and 3 units from x. The point 4, 0, 4 units along x and 0 unit above or below x. So since the y-coordinate is 0, that means that it lies along the x-axis. The point 0, -2 is a point along the y-axis since the x-coordinate is 0. The point -2, -4 is 2 units to the left of the y-axis and 4 units down below the x-axis. Finally, the point -4, 1 is 4 units to the left of the y-axis and 1 unit above the x-axis. Observe that every point in the plane has one and only one pair of coordinates. In other words, there is a one-to-one correspondence between the set of points in the plane and the set of ordered pairs x, y. Let us now extend our discussion in the context of surveying, more specifically for a traverse. So we have course AB and the coordinate axes. A is the starting station with coordinates x sub A, y sub A. The coordinates of point A are either known or assumed. It may start at the origin or at any other point in the plane. So let us assume that the coordinates of A are x sub A and y sub A. We determine the coordinates of the station point B and we denote the coordinates as x sub B and y sub B. Notice that the horizontal component of the course AB is equal to its departure and its vertical component is equal to its latitude. So clearly, to find the x and y coordinates of point P is to simply add to the x coordinate of A the departure of AB. This being the x coordinate of A and this distance is the departure of AB. So x sub B is equal to the sum. Similarly, y sub B, the y coordinate of point B, starts from the x-axis, which is equal to the sum of the y ordinate or y coordinate of A, y sub A, together with its latitude AB. So y sub B equal to y sub A plus the latitude of AB. We continue to our next station point C with coordinates x sub C and y sub C. We apply the same formula. To find x sub C is to simply add to x sub B the departure of line BC. And as for y sub C, that will be equal to the y coordinate of P together with the latitude of line BC. So we complete our traverse, the station point D with coordinates x sub D and y sub D. Their coordinates are determined by adding to x sub c the departure of CD and to y sub c the latitude of CD. As a check, when you calculate for the coordinates of A by adding to the coordinates of D, the departure and the latitude of dA, you should arrive at the values of the assumed or known coordinates of A. We now make the following generalization. If M and N are any two consecutive station points in the traverse, then the coordinates of N are x sub n equal to x sub m, the x-coordinate of the preceding station M, plus the departure of the course Mn, and y sub n is equal to y sub m, the y-coordinate of the preceding station, plus the latitude of the course Mn. So x sub n is simply the sum of x sub m and the departure of Mn, and y sub n is the sum of y sub m and the latitude of Mn. Let us now work on the following problem. The following table gives the adjusted latitudes and departures of a closed traverse. Given the coordinates of point A being 500, 500, we determine the coordinates of the other station points. So the x and y coordinates of point A are given. We calculate for the coordinates of the other station points B, C, D, E, and F. And we check by getting or calculating the coordinates of A. We begin by calculating the x coordinates. So for the x coordinates, we will be using the departures or the adjusted departures of the line. We start at the initial point or the station point A, whose x coordinate is known equal to 500.00. We now go to the second point, to the x coordinate of the second point B. The x coordinate of point B is equal to the coordinate of A plus the departure of AB, equaling 547.27. We proceed to station C. X sub C is equal to x sub B plus the departure of BC, equal to 1156.16. Next, for station D, x sub D is equal to x sub C plus the departure of CD, which is equal to 1942.94. Next is station E. X sub E is equal to x sub D plus the departure of DE, equal to 2161.26. Then x sub F. X sub F is equal to x sub E plus the departure of EF, equal to 1044.64. At this point, let us calculate for the x coordinate x sub A, which is equal to x sub F plus the departure of FA. Notice that we get a value of 500, which is the known or the given coordinate of point A, the given x coordinate of point A. We continue by calculating the y coordinates. So for station A, y sub A is equal to the given coordinate 500. Next, y sub B is equal to the y coordinate of A plus the latitude of AB, which is 990.71. The next, y sub C is equal to y sub B plus the latitude of BC, equal to 1577.83. Going to the next station D, y sub D is equal to y sub C plus latitude of CD, equal to 1250.42. Next, y sub e. Y sub e is equal to the y-coordinate of d plus the latitude of dE equal to 247.66. Next is y sub f. Y sub f is equal to the y-coordinate of E plus the latitude of EF equal to 124.99. And finally, we check on by calculating y sub a. Y sub a is equal to y sub f plus latitude of FA, which is equal to 500. So that means that our computations for the y-coordinates are all correct because we have returned back to the known coordinate of y sub a. Let us now summarize the result by tabulating the x and y coordinates of the points. We now proceed to the area determination by coordinate method. For any closed traverse with station points 1, 2 up to n, and with respective rectangular coordinates x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3 up to x sub n, y sub n, the area A of the track is given by the expression A equal to 1/2 the quantity x sub 1, y sub 2 plus x sub 2, y sub 3 plus and so on and so forth plus x sub n, y1 minus x sub 1, yn minus x sub 2, y1 minus and so on and so forth minus x sub n, y sub n minus 1. This expression can be written in the form of a determinant. We have here a equal to 1/2 x1, x2, x3 up to xn. These are the x coordinates of the points from 1 to n, and x sub 1 is repeated. The second row is comprised of y1, y2 up to yn. These are the y coordinates of the points from 1 to n, and the y coordinate y sub 1 is repeated. So what we have here is a determinant, or rather a matrix, comprising of 2 rows and n plus 1 columns. No? The first column representing the coordinates of point 1, second column the coordinates of point 2, up to the coordinates of the last point x sub n, y n, and we repeat the coordinates of point 1, x1, and y1. Now, once we have done this, the next step is to multiply or cross multiply the entries x1, y2, x2, y3, and so on and so forth up to xn, y1. We do the same thing for the diagonal to the left, x2, y1, x3, y2, and so on and so forth up to x1, yn. All products to the right are positive and all the products to the left are negative. So once we expand that, we will be getting the same expression given in our formula. Let us now have an example. So for the same tract of land we have considered before, and using the coordinates we calculated earlier, let us compute for the area of the tract. So we have the area equal to 1/2 of the so-called determinant, xA,ya, xB,yb, up to x sub f, yf, and xa, ya. Then we substitute the values. As for xA,ya, 500 and 500, xB,yb, xcyc, and so on and so forth. Again, last column, coordinates xa and ya. Then we cross multiply 500 times 990.71 plus 547.27 times 1577.83 up to 1044.64 times 100 minus the following products: 544.27 times 500, 1156.16 times 990.71 up to 500 times 124.99, and this is what we will get. Then we simplify and we will be getting an area of 1,715,096.28 square meters, and this value agrees with our earlier figure using either the DMD or the DPD method. Thanks for listening.